Testing a 74HC595 on a breadboard is a great way to understand how serial data becomes parallel output. Here is a manual static test method that doesn't even require a microcontroller, just your hands and some jumpers. 1. The basic setup, power and static pins. Before sending data, you must tie the control pins to a stable state so the chip doesn't behave erratically. VCC, pin 16. Connect to plus 5 volts. GND, pin 8. Connect to ground. OE, pin 13, output enable. Connect to ground. This enables the outputs. SRCLR, pin 10, reset. Connect to plus 5 volts. This prevents the chip from constantly resetting itself. 2. Connecting the load LEDs. To see if the chip is working, we need to monitor the outputs Q0 through Q7. Connect 8 LEDs to pins 15, Q0, and 1 through 7, Q1, Q7. Don't forget a 220 ohms or 330 ohms resistor for each LED to ground. Pro tip: place a 0.1 microfarads capacitor between VCC and GND on the breadboard to smooth out voltage spikes during switching. 3. The manual clock and data test. You can simulate a microcontroller by using jumper wires as switches. Follow these steps in order to write a 1 to the first output. 1. Set data. Take a jumper wire from SER pin 14 and plug it into plus 5 volts. This represents a 1. 2. Shift the clock. Take a jumper wire from SRCLK pin 11. Quickly touch it to plus 5 volts and then back to ground. This pulses the bit into the internal memory. 3. Latch the data. The LEDs won't change yet because the data is in the storage register. To see it, take a jumper from RCLK pin 12. Touch it to plus 5 volts and back to ground. Result: LED Q0 should now be on. 4. Testing the shift logic. To prove it is a shift register. 1. Move the SER pin 14 wire to ground, setting the next bit to 0. 2. Pulse the SRCLK pin 11, high then low. 3. Pulse the RCLK pin 12, high then low. Result: the LED that was on Q0 should move to Q1